Hello. So in this section, again, we're continuing our work on lines. And in this section, we're going to investigate more about gradients of lines. So again, last time, earlier on in the chapter, we discussed between 2 points, the gradient of the line was change in y over change in x. And that gave us a measure of how, I guess, steep the curve was, right? Now, in this chapter, we're going to look at things called parallel and perpendicular lines. Now, what we're going to look at is two different pairs of lines. And so, firstly, we're going to look at this sort of case. What if two lines have the same gradient? So we have this line here, and then what if it has the same gradient? Now, if they two lines have the same gradient, they will never ever intersect. They will never meet. Okay. If I was to continue this line on for infinity, likewise down here, they will never ever meet, no matter how far along I draw the line. And so when that happens, when two lines never meet, they are said to be parallel. Okay, and we denote parallel lines by this arrow there, to indicate that they never intersect. And what that means in terms of gradients is that the two lines have the same gradient, which means they never ever will meet or intersect. Okay. Okay. And so I guess if we call this line if that has gradient m1 and this has gradient m2, then m1 equals m2. Okay, remember we discussed y was mx plus c. M is the gradient. Okay, recall that. So if the two m's are equal to two gradients, that means they're parallel. Okay, but what also means, obviously, then if we if we change or alter the gradient of the line even ever so slightly, so say we have this line again, but this time I kind of not do that, but kind of rotate a little bit, and it looks a bit like that. Eventually they will meet. Okay, I mean, it's not a best example. Okay, but that that would be parallel-ish. But then say if we made the line just a little bit steeper, the second line, so I guess it looks a bit like that. Well, eventually these two lines are going to meet, right? And they're going to meet there, roughly. So even so the fact that lines go on for infinity, even if we alter the gradient even so slightly between them, that will then cause the lines to intersect at some point. So they have to have the exact same gradient, okay, in order for the two lines to never meet. Okay, well then we got the second case where actually they do intersect, but what happens when they intersect at a right angle? That means they form a 90-degree angle. We call this perpendicular. That means two lines, so that's parallel. So that means the two lines are perpendicular, okay? And so what that means in terms of the gradients then is that the two gradients have to be negative reciprocals of each other. So if I called the first line here M1, this line here, but then the other line, the gradient, if it's the negative reciprocal, so M1 has to be the negative reciprocal of M2, okay? So if we have M2, the negative reciprocal, well, negative 1 over M2. So 1 over M2 is reciprocal, remember? Then we do the negative, okay? And when that happens, they are perpendicular. That means they meet at a right angle, okay? So when they intersect at a right angle, okay? Cool. So that's what we're going to look at then. And again, this should be from GCSE as well, but that is essentially the a recap of what we've been using in this section. So two lines are parallel, again, if they have the same gradient, which means they never meet. Or if they do meet, they might meet at a right angle, which will then mean they are perpendicular, which then means the two gradients are negative reciprocals of each other. Okay, so let's have a look at that in action then. So let's have a look at some examples. So example 10, a line is parallel to the line 6x plus 3y minus 2 is equal to 0, and it passes through this point 0, 3. Work out the equation of the line. Now this is why I spoke about in the last section. This is why I love working with an equation of the line, which is mx plus c, because you can easily read off what the gradient and the y-intercept will be. But in this case, we're interested in the gradient because it's talking about parallel lines. So I need to consider gradients, okay? Because then they need to be equal. Anyway, well, this is not in the form y is mx plus c, this line here. So let's rearrange it then. So firstly, y has to be on its own there. So 3y firstly. If we move everything else to the other side, I'm going to get minus 6x plus 2. Then I can divide by 3 to get y is minus 6 over 3, which is minus 2x, okay? Plus 2 over 3. And there we are. Well, now this is in the form mx plus c. Well, then I can read off that the gradient is equal to minus 2. Cool. Well, so that's that line, but then it's telling me another line is parallel to it. So that means the parallel line has to have the same gradient. So the parallel gradient would also equal minus 2, okay, in order for the two lines to be parallel. That means then I can start to come up with the equation of the other line, okay, the parallel line that's parallel to this one, okay. So then that means y is minus 2x plus c. Again, I don't know what c is, but I can work it out. Okay, well then, to find c, well, I have this point here, right, 0, 3, that also lies on the line. I can then substitute it into here, okay, to then find the missing value c. So I'm going to sub the point 0, 3 into the equation. To then get y, well, y would be 3, and that's going to equal minus 2x, so it's going to be minus 2 of 0 plus c, okay? Well then, 3 will just simply equal c, okay? So c is 3, therefore y is equal to minus 2x plus 3, and there we are, that's our equation of the line. Cool, okay. Let's have a look at this example then. Work out whether these pairs of lines are parallel, perpendicular, or neither. And part A, it's told us the equations are 3x minus y minus 2 is 0, and x plus 3y minus 6 is 0. Okay, so 3x minus y minus 2 is 0. Okay, well, I'm not going to write the other one because it's talking about parallel or perpendicular lines. We saw that both parallel and perpendicular lines relate to the gradients. So what I need to do is to work out what the gradients of each line is. Well, I can't explicitly work it out because it's not in the form y is mx plus c. I need to rearrange all the lines into this form here, because then I can read off what the m is, the gradient. So that's what I'm going to do, rearrange every line then into this form, which will then allow me to work out clearly what the gradient of each line is. So let's rearrange this first one then. So then if I move the y to the other side, I'm going to get y is equal to 3x minus 2. But there we are, cool. The gradient there is 3. Then the other line is x plus 3y minus 6 is equal to 0. And then I'm going to rearrange for y again on its own. So firstly, 3y would be minus x plus 6 if I move everything else to the other side. Then y simply minus a third x plus 6 over 3, which would be 2. Okay, but therefore I can read off that the gradient is equal to minus a third. I should say gradient there as well, just to be a bit clear. Okay, so the two gradients that I have is 3 and minus a third. Well, they're not parallel because they're not equal. 3 is not equal to minus a third, clearly, so they're not parallel. Well then, are they perpendicular? Well, perpendicular, and as we discussed, are they negative reciprocals of each other? So 3, what's the negative reciprocal of 3? If you have 3 here, firstly then, we could take the reciprocal, which will then be a third. So that's reciprocal. Then the negative would then be times by minus 1. You get negative, you get minus a third. So that'd be the negative reciprocal of 3. Okay, take the reciprocal, which should be a third, then minus it to get negative. It's a negative a third. Well, hang on, isn't that the gradient of the other line? Well, that means that the gradients are negative reciprocals of each other, so they're perpendicular. So therefore, lines are perpendicular. Okay. As gradients are negative reciprocals of each other. Okay, cool. Another test actually then. Indeed, two lines are perpendicular if their gradients are negative reciprocals. But what that also means is that if we times the two gradients together, so say two lines are perpendicular, so that has gradients m1 and m2, right? If these two lines 1 and 2, again, any given line 1 and 2, their gradients, or if we times them together, it has to give us minus 1. Okay, so instead, I could have done 3 times minus a third. That would be minus 3 over 3, which would be minus 1. But therefore, that is the condition for the lines to be perpendicular. And it works out because if we just rearrange this equation, but then if I divide by m2, I get m1 is minus 1 over m2. Well, that is the negative reciprocal of m2. Okay, the gradient which is of the line 2, which is m2. So you can use either or, okay, but they're both exactly the same. The idea is you need to consider the negative reciprocal. Okay, cool. Okay, part B then. We have y is a half x. But this is already in mx plus c form. It doesn't have a y-intercept, but because it's plus 0 effectively. But m, the gradient, I can clearly see is a half. Okay, that means then that that gradient is a half. Okay, grad short for gradient in this case. Okay, well then what about the other line? 2x minus y plus 4 is equal to 0. Well, that again, I need to rearrange it in the form of this. Y is mx plus c. So I need y on its own. So I'm going to move that y to the other side to then get y is equal to 2x plus 4. Well, then we're cooking because now it's in this form. That means that I can read off that the gradient is 2. Okay. Well then, clearly they're not parallel because the gradients are not equal. Okay, a half is not equal to 2, so it's not parallel. Well, are they perpendicular? Well then, what's the negative reciprocal 2? Okay, well 2 would then go to minus a half. Okay, but I've got positive a half, so that's not the same. So they're neither perpendicular or parallel. Okay, so therefore lines are neither parallel or perpendicular. I guess as a justification you could say as they are not equal, which means they're not parallel, and if you times them together, their product. So and 2 times a half is equal to positive 1, which isn't 1, which isn't minus 1. Sorry. Because remember again, if you times the two, as we just I just discussed, if you times the two gradients of a perpendicular line, that should give us -1, okay? But in this case, it gives us +1. So we're out of luck, so it can't be perpendicular either. Okay, cool. Okay, let's have a look at this example. So given the line is perpendicular to the line to y minus x minus 8 is 0, and it passes through the point 5, 7. Find the equation of the line. Well, again, we're asking for a line that is perpendicular to another line, this one. So what I need to do is firstly to consider the gradient of this line to then work out the perpendicular of it. Well, then I need to rearrange it in mx plus c form. So then 2y will then be firstly x plus 8 if we move everything else to the other side. But then y would simply be a half x plus 8 over 2, it should be 4, okay? That means then the gradient is a half. That means the perpendicular gradient is going to be the negative reciprocal. So a half, the reciprocal of 1 over 2, if you flip the fraction, would be 2. Then the negative would just be -2. So that means the perpendicular gradient of a half will be -2. Okay, so flip the fraction and then put a negative on it. Okay, cool. That means then the equation of the other line that's perpendicular, I can then start to fill it in. So then y is mx plus c, well that would be -2x plus c, okay, because the gradient again is -2 there. Then to work out c, I can substitute a point in, so then I'm going to say sub 5 minus 7 into this line. Then the y coordinate's -7, so that means -7 is equal to -2 lots of x, well x is 5 here, plus c. Then I've got an equation to solve for c. So that means -7 is equal to -2 times 5 is -10 plus c. Therefore, c, if I solve that, I get -7 and add 10 to both sides to get c on its own. T would be -7 add 10, that would be +3. Cool. That means then, overall, the equation of the line, now that we have c, is y is -2x plus 3. Great, so now we've got the equation of that line. And there we are. So it's asked to find the equation of the line. There we are. Great stuff. So again, it's very, very, very similar, the sort of questions and the working, as we did previously, of finding missing points, of finding equations of lines and stuff like that. But this time we've got just one added ingredient, right? One extra added step of considering the gradients, okay? The parallel, perpendicular. But most of it's the same again, really. The sort of examples, questions that we looked at last time. So let's have a look at some more then. Okay, so this question saying the line L1 has equation 5x plus 11y minus 7 is equal to 0. Worthy noting that down, I guess. And it crosses the x-axis at A. The line L2 is perpendicular to L1 and passes through A. Again, there's kind of a lot going on. Let's kind of, I guess, draw a graph of it, of the situation. So we're given this line L1, crosses the x-axis at A. I don't know what the gradient or what it would look like, so let's just draw a generic line, say up there. It crosses the x-axis at A, so that's at A. Then the line L2 is perpendicular to L1 and passes through A as well. Now, if it's perpendicular, it's going to look like that, and it's going to have a right angle there, okay? So that's sort of the situation that's going on there. First of all, it's asking then to find the coordinates of A, okay? Well, again, we know L1 passes the x-axis at A again here, right? Well, the x-axis, well, A has the coordinates x0, right? If it's on the x-axis, then y is 0. So then we need to find the x-coordinate. Well, we know the point A also lies on this line here. Okay, because A lies on the line, I can substitute y0 in, right? So if y is 0, then we get 5x plus 11y, but that will go to 0 minus 7 equals 0. Then if I simplify to get 5x, that will go to 0. So then I'm left with 5x minus 7 equals 0, but I can move that to equal 7. I can move the 7 to the other side. Then I get x is 7 over 5. Cool. Therefore, the coordinate then is a is 7 over 5, 0. Nice. Then part B is saying find the equation of L2, okay? So, we're told that this line L2 is perpendicular to L1, but also passes through A, okay? But first of all, well, if it's perpendicular, L2, it's going to be the negative reciprocal of the gradient of L1. But you don't know what the gradient of L1 is, right? But then, again, we need to write, because it's not in mx plus c form, so I need to get it in mx plus c form to get m, the gradient. So let's rearrange. So we have 5x plus 11y minus 7 equals 0. Then I need to get 1, so let's do 11y equals minus 5x plus 7. Then I divide by 11 to get y is minus 5 over 11x plus 7 over 11. Cool. That means then that I can spot the gradient of L1, that's L1, right? It's minus 5 over 11, so that means the perpendicular gradient is the negative reciprocal. So minus 5 over 11, so firstly the reciprocal, that'd be 11 over 5 if we flip the fraction. And then we do the negative, but negative of negative, well that's two negatives, that'd be a positive, right? So that'd be just positive 11 over 5, okay? So the reciprocal, then negate it, but negative of a negative will give us a positive. So that would be our gradient. That means then we can start to complete our equation for L2. So it would be y is 11 over 5x plus c. Bearing in mind again, we have y is mx plus c for a general equation of a line. Then we need to find c. So we need to find a point to substitute in. Well, we know it passes through A. So that's our point. A, we already worked it out in part A. A in part A. So we can substitute that in. So I'm going to then say sub 7 over 5, 0 in, so therefore I get y, y0 in this case, 0 is 11 over 5 of x, which is 7 over 5, plus c, which that means that means I get 0 is equal to, and then 11 over 5 times 7 over 5, probably best and quickest do it in a calculator, because I'm too lazy. I get 77 over 25, okay? That means therefore, if I rearrange ever so slightly, I therefore get C is equal to minus 77 over 25, okay? Cool, well, that means my equation overall is y is 11 over 5x minus 77 over 25, okay? Cool. Okay, that's an equation. But then it's asking me to write it in this form here. So again, that means everything has to be on one side equal to 0. So that's what I'm going to do. So put everything here onto the other side with the y to then get minus 11 over 5x plus y plus 77 over 25 now equals 0. Okay, and actually now it's technically in this form. Okay, there we are. If you compare. However, I think it's best to tidy it up a little bit, because usually it does ask to give you answer of integers, so all the coefficients have to be integers and not a fraction. So it's best to clean it up, right? So we can say we can times everything by what to get rid of every fraction. Well, what number goes into both bottom parts of the fraction? Well, actually 25, right? Because 5 times 5 is 25, and obviously then 25 will then go into it. So if I times 25 by 25, we get 1. Okay, so that get rid of that, and then 25 times 5 will be 5. So times everything by 25 to get rid of both fractions. As again, 25 goes into both numbers on the bottom there, 5 and 25. Then I get minus 11 over 5 times 25. I get minus 55, okay, x, plus 25y, again, so then I'm times every term by 25, and then plus 77, okay, because 77 over 25 times 25 we get rid of the fraction to get 77, and that's again equal to 0, and there we are. Cool. So we've got a nicer form of our answer, and again you can see it matches this form here, so there we are, we're good. Great. Okay, but in actuality exams do like to throw you more sort of like geometric-ish question like this. So let's have a look. The points A and C lie on the y-axis, and the points B lie on the x-axis, as shown on the diagram. Okay, and they're giving us everything here, which is nice of them, I guess. Everything that's going on here. It says the lines for 3 points A and B here. So the line for A and B, which is that line there, right, is perpendicular to the line through points B and C. So that line through B and C is that one, and they're both perpendicular, so it's going to be like a right angle there. Okay. Find the value of C. So obviously the little c there, that's what I need to find, the y coordinate of that point there. So where that this line here passes through the y-axis there. Okay, so there's a lot going on. Okay, so let's break it down step by step. Let's see what we can work out first. Okay. So it's firstly talking about the lines of 2 points. Well, what do I know about a line through 2 points? The gradient, right? And also the gradient's probably what I'm going to do. I'm probably going to need to work out the gradients of the lines, because it's talking about the lines being perpendicular. Okay, so that's probably a good place to start. So firstly, we know what points A and B are, right? 0, 4, minus 3, 0, so I can compute the gradient. So I'm going to call that the gradient M of AB, okay? So a subscript, so a smaller, the smaller letters AB under the M, which means the gradient between points A and B. Well then, okay, so the gradient between points A and B, which is also the gradient of this line then, well, it's just changing y, changing x, isn't it? And again, you don't have to write that down, but I'm just writing it down to be explicit about what I'm about to do. Okay, well then, the change in y, the y coordinates, let's do A first. So let's take 4 as the y coordinate there, and then take away by the other y coordinate at B, okay? So before minus 0, then I need to then use A again, so x is 0 here. So changing an x now, take away the x values. 0, take away the other x value, which is at minus 3 at B. So minus of minus 3, because I'm taking away minus 3. So I get a double negative, so then I can simplify it to 4 minus 0 is 4. 0 minus minus 3 be plus, so it'd be 0 plus 3, which is 3. Okay, well that's our gradient then, between points A and B. Cool. Okay, well then it's saying that this other line then, that passes through B and C, so this other line here, which again means it's at right angle when they intersect. Well, it's saying that they are perpendicular. So what does that mean with the other line then? If AB, this line AB, is perpendicular to this line BC, well, what does that mean for its gradients then? The gradients are negative reciprocals again, right? So if I know this one is 4 over 3, that gradient, then that means the perpendicular gradient of 4/3, well, it's a negative reciprocal. So let's take the reciprocal. Again, reciprocal just means flip the fraction. So do 3 over 4, then minus it, okay? So it's minus 3/4. Well, then that means the gradient of BC is equal to minus 3/4, as again that would be the gradient of the line BC here, which again we're told is perpendicular to the other line that's passing through AB. Okay, cool. Okay, then it's again then okay, we worked out quite a bit then. So then what's it asking us? To find the value of C here, the little c, which again it's this point here, a big C. So we need to find when this line BC passes through here. Well, I need the equation of the line, because I'm going to substitute a point in, or find a point, I need to find the equation of the line. Okay. Well, okay, so the equation of the line of BC, the line is equal to y is mx plus c. Again, that's every line, that's a general line. So we need the gradient and the y-intercept c. Well, well, we just worked that out. M is 3 minus 3/4, so it'd be minus 3/4 x plus c. Cool. Okay, well, then, we need to find the C here. I should probably use a different letter, but, because it's not the C here. Well, actually it is, but, it turns out it is, but, not always. But it's probably always best to use a different letter if you're working something else out than in the question. So they're using C here, and I'm working out perhaps something else. It's probably wise to use a different letter here. Let's use plus K, okay. But actually it turns out the C is the same, because this is the y-intercept, so that is the same C there. Anyway, so we need to find the missing letter. Okay, we need to find the y-intercept of this line here. Well, I need a point on the line on BC to then find that missing letter, that K. Okay. Well, I know a point on the line. I need to find C. I don't know what C is because there's a missing letter, but it also goes through B, and that is minus 3, 0. So I can substitute that in. So I'm going to say sub minus 3, 0. So then get y, well, y would be 0 in this case, is minus 3/4 of minus 3 for x plus k. Okay there. Okay, well then I can simplify. So 0 is minus 3/4 times minus 3 plus 9 over 4. Okay, plus k. That means that k is minus 9 over 4. That means my equation of the line is y is minus 3/4 x minus 9 over 4. Okay. Okay, well then we need to find this c. Okay. However, it turns out that this is equal to k. This is the y-intercept at minus 9 over 4. Why? Because yes, because k is the y-intercept, right? That's what we worked out, and this is the y-intercept, right at c. So therefore I can quickly read off that therefore y at c is equal to minus 9 over 4 as well. Okay. Alternatively, if you didn't realise it was the y-intercept, or I don't know, maybe you're not really thinking about it, you're in like machine mode and you're not really trying to think about it in an exam situation, you could just substitute the point in and then find it that way. If you didn't realise it, you'd then see that. So then I can substitute the point C in, the big C, to get this little c. So then if I then say substituted 0 little c into the equation here, I would then get y would be c, and then x would be 0, so it'd be minus 3/4 of 0, minus 9 over 4. But then voila, c is also minus 9 over 4, so that is indeed the y-intercept, that point c. Okay, so therefore, there we are. Now, I probably didn't explain it too well, but I made a little bit of a fuss by saying using the different letter k here compared to c. Because again, you might not have realised, well, actually that was actually the C, the K working out. Usually the y-intercept is indeed the same C there, which is the y-intercept. But in general, if you're trying to work out an unknown value, that's different to perhaps what the question's saying. So if I worked out something else that isn't C, I don't know. Say if I was working at this point here, I wouldn't call it'd be different to C, so I'd have to use a different letter there. But in general, what I'm saying is with questions, again to reiterate, if the exam questions asking you to find a letter, find one unknown, right? In this case, it's C. If you then need to solve something else that's unknown in your question, you should use different variables, okay, to not confuse yourself and not to suggest that the values are a value is different to what you're saying it is. So with any variables that you solve or any unknowns that you solve in your question, you really should make the letters different, okay, to not essentially not confuse yourself, or make it suggest that you did the wrong answer, because you conflate the variables. Anyway, let's move on from that. Okay, and actually, it turns out because of this, but the fact that parallel lines never meet and perpendicular lines meet at right angles, it does allow us to actually then solve problems with shapes, with 2D shapes or whatever, right? Because a lot of shapes have parallel lines. So, for example, a rectangle or parallelogram, that's the top line is parallel to the bottom line, and the sides are also parallel to each other too. So that we could actually formulate that as finding in the equation of the lines and the gradients, and then recognizing the gradients are the same, which will mean the parallel. And then you could actually prove that certain shapes are indeed like a rectangle or parallelogram or so on. And in this case, they want to prove that this shape that these 4 points make are a trapezium. Okay. And again, this does come up time and time and again with various topics. That sometimes questions are asking you to prove a certain property of a shape. So you do need to remember these shapes from GCSE or even younger than that. And in this case, a trapezium looks a bit like this. And the key property of a trapezium that we will be proving is that exactly one pair of sides are parallel. In particular, the top and the bottom side. The sides don't have to be parallel. We only require that one pair of sides are parallel. Okay, that's what we want to prove. Okay. So if we can formulate the 4 sides A, B, C, D of this quadrilateral, then we can sort of perhaps find the lines or find the gradients, and then we can use that to determine that 2 lines of that shape are parallel to each other, which will then prove it's a trapezium. Okay, so then I'm going to start off by saying trapezium, or trapeziums in general, have one pair of parallel sides. Okay, that's the key defining property. Okay, cool. Okay, well then, it's given us these points here. So I think it's really helpful then to actually plot the points then, and then we can sort of visualise what the graph will look like. So let's plot our points on, and I think that's the best strategy with these sort of questions, is to plot points to see what you're working with. So first of all, the point A is minus 6, 2. So on negative x, and then it's going to be 2 up there, so it's going to be up there, say, and that'd be A. Then B is 4, 8, so it's going to go up here somewhere. So 4, 8, that's point B. Point C would be 6, 1, so that would be down there somewhere. Then D is minus 8, minus 9, minus 8. So that's going to be all the way like down here, right? And that would be point D, okay? Okay, well then let's connect let's draw what the shape would look like. Let's connect the points together. So D to A would be there. Then A to B would be there, B to C there, and then D to C would look like that. There we are, and you can start to see we have a trapezium shape, okay? And in particular, what you would expect from this graph, you'd probably see that the line AB would be the gradient of the line AB is going to be parallel to DC, so the top and the bottom sides are going to be parallel. That's probably, visually from what I'm seeing, that's probably the sides we're going to have to consider, although we might be off. Maybe these sides are parallel instead. I don't know, but visually it looks like A, B, and DC, right? So let's consider those sides, right? So that means then, if these two sides are parallel, the top and the bottom, like A, B, and DC, the two top and bottom, if they're parallel, that means their gradients have to be equal. So let's consider the gradients of those points, okay? So firstly, the gradient of the side AB, again, that's going to be the change in Y. So firstly, I'm going to take between A and B, I'm going to take B to be the first point. So B, firstly, is the Y is 8. And take away the other Y value, A, that'd be -2, okay? Then, that'd be out of, then the change in X. So X at 4 there, and then take away the other X at -6. So minus 6, we can simplify that to 8 minus 2 is 6. And then have a double negative, that'd be a positive. So 4 plus 6 is 10. And that will simplify down to 3/5, okay? Then we can work out the gradient of the other line, CD, and so this line here. Well, then again, I'm going to take between point C and D. Let's take D first. So again, changing Y, so let's take -8, and then take away the other Y value at C. That'd be -1. Then I'm going to take away the X values together. So -9 here. Take away 6. And so that would get me -8 minus 1 being -9. Over -9 minus 6 is -15, okay? And actually what turns out is that simplifies to +3/5. Well, what do you know? The two gradients are indeed equal. So that means MAB is equal to MCD. So gradients are equal, which means that lines AB and CD, which were the two gradients we worked out, are parallel, okay? Therefore, there is one, or I probably should say at least one. But we can say there is basically, there is one pair of parallel sides, right? At least, but there is one pair of parallel sides in the shape ABCD. Therefore, ABCD must be a trapezium. Cool, because remember the defining property was that trapeziums have one pair of parallel sides. Okay. Cool. Let's have a look at this question then. And again, it's another shaped geometric question, very, very similar. But again, we can use the sort of ideas of parallel and perpendicular gradients and lines to work out what we need to work out. So again, we're given vertices of another quadrilateral ABCD, very similar, but this time we need to show it's a rectangle. Again, so like the trapezium, what exactly is a rectangle? Well, obviously it looks like this. We also know then that the two sides are going to be parallel, this side and this side, but also this time these sides as well, okay? And also, as well, every angle inside is 90, okay? So actually there's a lot more to consider in this case. Well, firstly, how the parallel line aspect to it. How can we prove two lines are parallel? Well, we just did it. Their gradients have to be equal. But then how do we deal with this 90-degree business? Well, if two lines are perpendicular, so we have a right angle at these two lines, that means they're perpendicular. So we're going to use a combination of parallel and perpendicular aspects to this problem, parallel and perpendicular gradients, to be able to work out this question. So then a rectangle then, to summarise, has two pairs of parallel sides and each angle inside is a right angle or 90 degrees. Okay, obviously you could call that an interior angle to be fancy, but yeah, every angle inside the shape has to be 90. Okay, so that's the key defining property in this case? Well, so let's get to it then. So firstly, like with last time, it's a really good idea, I think, to plot these points in, to visualise the type of graph, the type of shape we're working with, what exactly the shape will look like. So let's draw our axis then. So let's plot the points. So A is firstly at minus 1, 5, so it's going to be up there somewhere probably. Then B is 7, 1, so it's going to be like there somewhere, B. Then C is 5 minus 3, so that's going to be down there somewhere. And then D is minus 3, 1, so it's going to be up there somewhere probably. Cool. So there we could plot the points in. So yeah, D to A, then A to B, if we can sort of draw this properly. B to C, and then back from C to D. And again, you can start to see we've got a sort of rectangle problem again, right? I mean rectangle problem, of course. It starts to look like a rectangle again. Like last time, it looked like a trapezium. So it really is a good idea to sketch to visualise exactly what you need to consider. Well, what are we considering then? Well, firstly, the line AB is going to be parallel clearly to DC. And then, likewise, AD is parallel to BC, because we have to consider it's a rectangle, so both sides, both pairs of sides have to be parallel. And also, probably going to have a perpendicular angle there, so right angle between AD and DC. But yeah, cool. So let's work out the parallel aspect first. That's probably the easiest. So firstly, let's consider the gradient of AB. So the gradient of that point between points A and B, well, that's again a change in y, change in x between B and A. Let's take B first. So the y is 1. Take away the y at 5. Y here is 5. Then change in x. So let's do 7 here. Take away minus 1. Well, that will simplify to 1 minus 5 is minus 4. And then plus here is a double negative. 7 plus 1 is 8. That will simplify down to minus a half. Okay. Then the other, then what we suspect is the parallel side, right? The parallel to AB is DC. Okay, so MDC or CD, doesn't really matter what you call it, but DC. Again, we would work out the gradient between those points. So D, firstly changing y is 1, take away minus 3. Then we're going to have change in x, and minus 3, take away 5. And that's going to get me 1 plus 3 is 4, and then minus 3 minus 5 is minus 8, and again that would be minus a half. Great stuff. That means that therefore, because these two gradients are equal, I'm going to say MAB is equal to MDC, so the gradients are equal. Therefore, lines AB and DC are parallel. Okay. Cool. But that's one set of lines parallel, but then I need to consider the other set of lines, BC there and AD there, right? So then let's consider the other lines. So let's first consider AD. So first of all, the gradient between A and D. Let's take D first. So changing Y, so I'm going to have 1. Take away 5 there from A. Then I'm going to do change in x, so let's do minus 3. Take away minus 1. That gets me, 1 minus 5 is minus 4. Minus 3 plus 1, double negative, will be minus 2, so that would be positive 2. Okay, but then I'm going to do the same for the other line, BC, MBC, that line there. So the opposite left AD. So then MBC, again, the gradient between B and C now, here and here. Well, let's take C then. So changing Y, so minus 3. Take away 1, the Y coordinate at B. Then I do change in X, so I do positive 5, take away 7. Then minus 3 minus 1, would be minus 4, and then 5 minus 7 is minus 2, and that would get me again positive 2. But then how do you have it? The gradients again, MAD is equal to MBC. Therefore, again, the lines AD and BC are parallel. Well, there we have it. We proved that both sets of sides are parallel, but with a rectangle, that would be a parallelogram. A parallelogram is where all sides are parallel. However, not necessarily right angle. Okay, a rectangle is a type of parallelogram, but we need to be more specific, and the angle inside has to be 90 each time. So how do we do that? Well, what do we know about lines? Well, perpendicular lines, again, if they're perpendicular, they meet at 90 degrees. So we could consider when two lines on the side, so two different sides, meet, and what their gradient will be. They're perpendicular. Okay, so let's consider whether two sides are perpendicular, because then that means if they meet at a right angle at 90. So let's take this here. Right, it's a bit messy here. There we are. Let's consider when the line AD here and the line DC meet. So then let's consider the gradients. Okay. So let's see they're perpendicular. So first of all, MAD is firstly. Well, we worked it out. That's 2. Okay. Well, what's the negative reciprocal of 2? Well, the reciprocal of 2 would be a half. The negative is minus a half. Well, then what's the gradient of the other line, CD or DC? Well, we worked that out. That MDC is minus a half, right? The gradient of DC is a minus a half, and the gradient of AD is 2. Okay. Well, so that means perpendicular gradient of 2 again is going to be minus a half. Again, reciprocal, negative it, but minus a half, that's equal to the gradient of DC, right? So that means then if AD's there, BC, DC's there, but then that's telling us that the perpendicular, they meet at a right angle. But that means that therefore lines AD, line AD is perpendicular to DC, okay? Because the gradient of AD is 2, and that's the negative reciprocal of DC, okay? So DC and AD are perpendicular, sorry. But then that means that the angle here, angle ADC, is equal to 90. Okay, it's a right angle. Okay, well that's proving that that's proving that one angle inside is 90. But actually that turns out that all angles in the rectangle, again, if I draw this shape a bit more nicely, no, let's draw a rectangle. So I've worked out that this angle is 90. Oh, awful sketch. So I've worked out that this angle is 90, right? That is ADC. But it turns out that all angles have to be 90 as a result, without doing any extra work, because in a because it's a parallelogram, because as we discussed, all pairs of sides are parallel. Parallelogram, opposite angles are equal, so that means this is also 90. But then that means that this angle here is equal to that angle. But then we also know angles in a quadrilateral add up to 360. So if these two right angles add up to 180, that means that therefore these two angles as well, these two other opposite angles also have to add up to 180, but they're equal. Well, two angles x has to equal 180, that means the angle is 90. But that means the other two angles therefore is also 90. So without doing any extra work, that means by because of the fact that the lines are parallel, all of them, the two different sides of parallel lines, that means all angles are 90. So therefore, that means the overall shape ABCD is a rectangle, as it has two sets of parallel lines, as we worked that out. Two sets of parallel sides and angles in the shape are right angles. Okay, and there we are. There we are. Therefore, we proved it's a rectangle. Okay, that was a lot. That was okay. But yeah, hopefully you can kind of start to make sense of that, right? How you would approach these type of questions, okay? And in this case, it's helped to a lot of shapes, a lot of the properties boil down to whether the angles are right angle or if they're parallel, or certain sides are parallel. If you think of it in terms of that, then it's helpful to consider the gradients, okay? And it's also helpful to visualize by plotting the points in. Then it becomes a lot clearer about what you have to do. But yeah, hopefully it starts to make sense. There is a lot, that question though. But yeah, we got there in the end. Cool. Okay, let's have a look. Let's finish off an exam question, which actually is easier than the stuff we've just done. So it's told us this line L1 has equation 2x plus 4y minus 3, 0. That's probably going to be helpful. The line L2 has equation y is mx plus 7. Given that the two lines L1 and L2 are perpendicular, first of all, find the value of this m here. So again, they're perpendicular, so I need to consider their gradients, okay? Well, I don't know what the gradient of L2 is, because that's what I'm working out. M is the gradient here. But I know what L1 is. I'm given the equation of L1. But I don't know what the gradient is because it's not in the form y is mx plus c. So I need to get it in that form to be able to spot what the gradient of the line is. So let's get y on its own. So 4y firstly is minus 2x plus 3. That means that y is minus 2 over 4, which should be minus a half, x plus 3 over 4. But therefore the gradient of L1 is minus a half, as you can spot there. Okay, but then the gradient of L2, well, L2 is perpendicular to L1, so again it's going to be the negative reciprocal. So that means the L2 gradient, if you take the negative reciprocal of this one, the other line, well, 1 over 2 reciprocal, flip it, you get 2 over 1. But 2 over 1, well, divide by 1 is just itself, so we get 2. And then we're doing minus, so minus of minus 2, well, that'll become a positive. So the gradient overall is positive 2. If you take the negative reciprocal, so reciprocate, I guess, 1 over 2 to get 2. Then negative it, so negative 2 would be positive 2. Okay, cool. So we've got the gradient. So again, we can start to work out what the gradient of L2 is. So that means the L2, the equation is y is 2x plus c. But hang on, they've told us what the equation of L2 is, really. It's in the form y is mx plus c. So really, we don't need to do any work. We don't actually need to do this. Because, again, this equation is in the form y is mx plus c. The c is 7, but m is the gradient. But we worked out what the gradient is It is just here. So that means m is 2. Cool. Then part B. Then it says, the lines L1 and L2 meet at the point P. Find the x-coordinate of P. So again, that's then considering intersections. So the two lines intersect, that means we need to equate them together. Well, we know the equation of L1 is 2x plus 4y minus 3 equals 0. That was given to us there. But we also know what L2 is now, because L2 is y is mx plus 7, but we know that m was 2. We worked that out, so it'd be 2x plus 7. Well, these are simultaneous equations, right? So I can solve that, substitute it to get the x and y. So that would be the point of intersection if I equate them together. So that means I'm going to sub y into 2x plus 4y minus 3 is equal to 0. So I'm going to substitute one equation of the one line into the other, okay? So that means then 2x plus 4y, well, y is now 2x plus 7, which is again there. Then I get minus 3 is equal to 0. That means then 2x plus 4 times 2x is 8x. Then 4 times 7 is plus 28 minus 3 equals 0. Then 10x plus 28 minus 3 is plus 25 equals 0. But then I can easily solve for x. So that means x is minus 25 over 10. I don't think that simplifies. Oh, it does. 5 minus 5 over 2. There we are. Now we would solve for y, right? To find the missing value, to find the point. But actually, it only says to find the x coordinate. So that means the x value. Well, we just solved that. Okay. So actually, we're done. So there we are. Cool. So there we are. That's parallel and perpendicular lines. So again, mostly it's the same sort of stuff we looked at previously in the chapter. Just some sort of algebra problems. You have to rearrange to spot the gradient. You need to find equations of the lines by substituting points in order to work out a gradient by doing changing y, changing x. But I also looked at some more geometric problems where we can prove certain stuff of shapes by considering the gradients of the sides of the shapes, okay? And if they're perpendicular, they have a right angle. If they're parallel, then that means there might be some sort of parallelogram or something like that, so they never meet. But yeah, that's parallel perpendicular lines, so I'll see you next time.